Hey there, welcome back. So this section, as well as the next section, they're really one massive section, but I split it in half just so I don't end up with this one behemoth section. But both of them have to do with algorithms and problem-solving patterns or strategies, game plans, approaches, whatever you want to call it. Basically, you're faced with a tough challenge, some code or a problem you have to solve, and you don't know how to do it right off the bat. What are the steps you can take to make it solvable? And it really falls into two categories. This first section is more about the basic approach to solving a problem you don't know how to solve. Steps you can take, things you can do to make it easier. And then the second section that comes after this is about specific blueprints or archetypes, little strategies you can keep in your back pocket that help solve a lot of problems. So it's more code specific in the next section, but both are equally important. But first, objectives really quickly. We're going to start by defining what an algorithm is in like 10 seconds. Devise a plan to solve algorithms, and then compare and contrast problem-solving patterns, including things like frequency counters, two-pointer problems, and divide and conquer. So that's coming up in the next section. Like I said, this section is really more focused on devising a plan, sort of an approach to solving problems. And then afterwards, we'll dive into specific named patterns. Okay, quickly, what is an algorithm? Well, in today's world, it's like the trendiest of the trendy buzzwords. I was watching an ad the other day I was on Instagram, and there was an electric toothbrush, and they were advertising, this finely tuned algorithm for the vibrations in the toothbrush. It's a word that you can't escape. Really, it just means a process or set of steps to accomplish a certain task, a rather underwhelming definition. But that's all that it is. So when we say algorithm, we could be talking about, a set of mathematical steps that we need to do to solve a problem. We could be talking about Facebook's algorithm that, suggests certain ads to you, or Google's algorithm when you search for something, where it's a matter of, 50 developers working together. It's probably vastly underestimating it. Maybe 100 developers who are working on search result algorithms over, 10 plus years. So it really runs the gamut, but at its core, it's just a set of steps to accomplish a task. So that could be something simple like, calculate the first 100 prime numbers. There's many ways of doing that. Or it could be something like, Instagram's algorithm that used to just show you results in chronological order, and then they decided to change it, and now you miss a million posts by your friends. Anyway, why do you need to know this? Well, hopefully this is sort of clear already. Almost everything that you do in programming involves some sort of algorithm. Whether it's super basic things that you're doing or you're building a complex application, you have to make these decisions. You have to come up with a way of solving problems. So this stuff is super important. But I do want to sort of constrict our definition of algorithm for now. We're not going to learn how to solve Instagram's timeline algorithm. We're focusing on really a much narrower category, and that is things that come up in interviews. So this is probably why a lot of you are taking this course. Yes, this stuff is good to know. Especially this section applies to a lot of programming, pretty much everything, but it also really applies to interview settings. Being able to, sit in an office somewhere you've never been and answer tough questions or solve a problem you've never seen before. So just to reiterate, this stuff comes up all the time in interviews. Oh boy, how many of these did I do? Okay, interviews. There we go. So how do you get better at this stuff? A lot of people think this is just inherently, people are good or bad at it. And I've seen that a lot when I'm teaching. Some people are just naturally better at solving problems, I would say, or their brain works right out of the box at solving problems. But that doesn't mean that it's hopeless for people who struggle. I've seen it many, many times in my classes during our interview weeks towards the end, where we're doing computer science and sort of what this course is based off of. Some people pick it up much faster. Other people have to work towards it, just like anything in life, honestly. But I've seen many people turn it around and struggle during our first mock interview and have a panic attack basically in the middle of our conference room. And then a week or two later, brand new problem they've never seen before, equally as difficult, they're able to sit there calmly and solve it using some of the steps I lay out here. So how do you improve? There's two things. I've already mentioned this. First, devise a plan for solving problems. So this is more of a non-technical, it still is technical, but it's more about How do you approach a problem? Strategies for breaking it down. There's a couple steps that I recommend. And then afterwards, master common problem solving patterns. So a lot of algorithms, especially in interviews, a lot of these problems that come up can be broken into sort of different categories. And if you can identify some of those categories, there are some steps you can take in your code, some recipes you can keep that you can pull out and that will help you solve the algorithm or the challenge. We're starting off with this first one. Problem-solving strategies. So this section is focused on a simple, foolproof, magical, miraculous, fail-safe approach to solving every problem ever, which can be yours for only 2 payments of $999.99. Call now. No, not really. This is not at all what this section is about. This is just laying down a set of steps that can help you, but of course it is not going to solve the problem for you. It's not foolproof, but I've seen many people, like I've already mentioned, turn their problem-solving approaches around. Many people who have gone from feeling really apprehensive about solving new problems and lock up in the middle of an interview setting, and giving them sort of a game plan, a set of steps that you can keep in your mind is a concrete thing to refer back to, step by step, what you should do. And I've seen it help a lot of people. So it's not miraculous, it's not magical or foolproof, but still is pretty helpful. So what are those steps? Well, first, understand the problem. So each of these bullet points will get its own video. Understand the problem, explore concrete examples, break it down, solve/simplify the problem, and then look back and refactor. So these are the different videos we're going to have in this section. Each of these points, there's a lot more behind it, and each one is part of this plan, this game plan, this recipe for solving a challenge or a problem. So that's where we're going here. And then the next section is on more concrete archetypes for algorithms, but we're starting here. All right, so problem solving, hopefully you know why this is important. Don't make me go back to this slide. It's too many button presses. Interviews, yeah, great stuff. Okay, let's get started in the next video.